I needed to find a way to display the duration of employee vacation. There might have been an easier way to do this, but this is the best way I found to visualize this data. So it's pretty simple. All you have to do is type the calendar chart function, enter the month name in words, the year, the number of columns the chart is from A, the number of rows the chart is from 1, the array of start dates, and the array of end dates. Make sure everything is set to absolute references, drag the formula across 7 columns and 5 rows down. And that's it. Well, that would be it if you did all of the other parts first. That was actually the last step in the process. To get to that point actually took quite a bit of formula writing. This is how I got a calendar that shows duration data in Google Sheets. I had a much more complicated method that needed 3 different groups of cells to do the calculations, another for the dataset, and a 5th one for the conditional formatting. So before we go over the simplification steps I took, let's look at the original concept. The main calendar formula looks like this. The calendar works by converting each date into a point on a coordinate system where weeks become the y-axis and days become the x-axis. Where a week and a day intersect, we have a specific date. Google's weekNum function returns the number of weeks for the date in regards to the corresponding year. This would be great if I had an entire year of months to display, but I'm only displaying 1 month at a time. To get the week in respect to the current month, I minus the week value of the last day of the previous month in question using the EOMonth function with a -1 month value. I can get the day of the week using the weekday function. Now that I have an X value, the day, and a Y value, the week, I need a way for Google Sheets to know where to put the data. I can use the spreadsheet's existing rows and columns to do this. A1 being Sunday of the first week and G4 being Saturday of the 4th week. Now all I need to do is to check which cell the formula is in and see if any dates have that same cell value. In this case, G1 is the same as Saturday in week 1, which is the date of Saturday, January 1st, 2022. Any date that has a row value of 1 and a column value of 7 will be placed in this cell. Because the formula works by checking what cell it is in, the entire calendar can have the same formula in every cell. Now, if I want to move the calendar, I can add an offset value to place it where I want to on the sheet. To get the amount of people on vacation for each day, a formula in another range that looks like this counts all entries whose start date is less than or equal to the current date, which means the start date is either the date of the corresponding cell or before. The entry also needs to have an end date that is greater than or equal to the current date. This means that the end date is either the cell's date or after. This means that an entry will be counted on all days from its start date to its end date. Another range cleans up this data by ignoring all entries that are less than 1. The second part of the main calendar formula takes this data and wraps it between brackets if there's a value to show. As you can see, this does work, but it's extremely inefficient. I realized this when I tried to move the calendar from one project to another and it just broke. I needed to create a version of the calendar that was much more portable. The first step to this was to come up with a design for the date listing that didn't require a secondary range to list the dates. The simplified formula looks like this. Now, I know it still looks complex, but it eliminates the need for a second range listing the dates by using the sequence function wrapped in curly brackets. This returns an array that the filter function can use. The sequence function lists all of the dates from the start to the end of the month, but instead of listing them on the sheet, they are contained in a formula in the form of an array. The final formula looks like this. This formula is split into 2 sections. The first builds a calendar, and the second formula sums all of the entries whose dates pass through the date being evaluated and surrounds this value in brackets. The functionality of this formula is similar to the previous system, except the method of enclosing the value is part of a single if statement, which checks if the count is greater than 0 and then surrounds this value in brackets. To get the different colors, we can use conditional formatting. It's a bit tricky because the value we need is part of a string with another number value, but those brackets aren't there by accident. We'll use a bracket to extract the number and use that value for the conditional formatting. The formula I use looks like this. I'm not going to explain this formula in this video, but it's basically looking for the value between the brackets and in this case, checking to see if that value is greater than 0. The final step is to turn it all into what Google calls a named function. To be honest, this script was almost finished before I found out this was even a feature, but it's super useful. If you tend to use long, complicated formulas in multiple places, this can help. The name function allows you to take this complicated formula, assign variables to each repeated value, and now you have a single formula that can be repeated anywhere. If you found this video helpful, let me know by leaving a like and feel free to leave any questions in the comments.